Hello and welcome to the Features of Sine and Cosine Functions Day 2 video. In this video, we're going to be continuing what we did in our last video of identifying features as well as finally putting them into equations. So let's get started. Just a reminder, our overall equation is y is equal to a times sine or cosine of b times theta or x minus c plus d, where a is your amplitude or vertical stretch, where d is your midline or vertical shift, b is your frequency, and you use the period to get to that, and then your phase shift or your horizontal shift is that C value with the flipped sign. So let's go through, take a look at this graph, find those features, and then we'll finally be able to write the equations. So first thing I'm going to do is I'm going to try and find that midline. So I see at the very top of my graph here is at 2, and the very bottom is at -4. So if I kind of count inward from both sides in each direction, I see we meet at -1 here. So this is the horizontal line in the middle of my graph at -1. So we have a midline at -1. Next, we'll take a look at our amplitude. This is the distance from the midline to the very top of the graph, or midline to the very bottom. So if we take a look from here, from the midline to the very top, I can see that that is a distance of 3. Saying we're going to have an amplitude of 3, or there's a stretch of 3. So before we can get to the frequency, we need to know the period. So when we take a look at the period, it's how long it takes the graph to repeat itself. So we can look top to top, bottom to bottom. If I take a look from here to here, top to top, how long does it take to repeat itself? Well, that right there, that period is a distance of pi. So it takes a length of pi to repeat itself. Now our frequency is how many periods or how many full cycles do we have in a specific interval, with that being interval of 2 pi. So we're going to do 2 pi divided by the period, or in this case 2 pi divided by pi, which gives me 2. So this tells me that in an interval of 2 pi, for instance, if I start down here when my theta is 0, we have 1, 2 full periods. So we look from 0 to pi, and then from pi to 2 pi, we have 2 full cycles in an interval of 2 pi. So we have a frequency of 2. So before we get to our shifts, I want to actually write our equations. Because the really cool thing is, I'm going to have you write 2 equations, and our midline, amplitude, and frequency are going to be the exact same for both of them. The only difference is going to be the shift. So let's get started. Both of them are going to have y is equal to an amplitude of 3. Let's say that top one's going to be cosine, that bottom one's going to be sine, of a frequency which is 2 for both of those, parenthesis theta, and then I don't know what the shift is yet, so I'm just going to kind of leave like a blank space for that. And then with the midline of -1. So if you're having trouble finding your shifts or determining your shifts, if you can at least get me this is most of the information. So remember, your amplitude, your frequency, and your midline are all the same for both of these equations. The only difference is the shift. Now, when we think about our shifts, the first one we'll have is cosine. Cosine has its parent graph with a y-intercept at the very top of the graph. So now we can decide which way we want to move. Do we want to move this? Are we looking to the right or to the left? I always like to go for positive shifts to here. So this is cosine with a shift of pi over 2. However, if you decided to go the other direction, that's okay as well. If you decided to go to -pi over 2, your equation will just look slightly different than mine, only in the shift. So just make sure you have a correct shift, and I will accept it. But if we were choosing a shift of positive pi over 2, then in my equation, I'm going to put minus pi over 2. You have to make sure to flip the sign. Now for our sine function, sine is has an original y-intercept in the middle of the graph, and it's moving upward. So if I were to go backwards here, that's not a good y-intercept or a good shift because it's moving down through the midline. So if I wanted to, I could go all the way out here. Pardon me, not there. I could go all the way out here if I wanted, but that seems kind of far. So I'm just going to go to right here where we are moving up through the midline. So this is for sine, and that was at pi over 4. So when I write it in my equation, that's going to be minus pi over 4. And we are done. So if you want to just write everything else out before you find the shift, that's okay. You can do it all at once. But this is us finding all the information on a graph and then writing the equation. So let's try just one more problem. So what if we don't have a graph? What if we're just given the information? Let's move down to problem number 5. So problem number 5 says here, given the features of the graph, write the equation for sine or cosine and explain your thought process. So I don't have to find all this stuff. It's already telling me all of this information. So I know my amplitude, my frequency, my midline, and my phase shift. It's perfect. I move this to the side just so that we can still see our equation up here. Make sure we know where to put everything in. So let's see, this is going to be y is equal to our amplitude of 3 times sine of our frequency of 2 times theta minus 20 degrees, oops, plus 4 for our midline. So we're just plugging it all into the equation, and that's it. We're done. Just things to keep in mind is that I wrote a minus 20 here because I had to flip the sign when I'm dealing with a phase shift or horizontal shift. And lastly, in the last equation, we wrote an equation for both cosine and sine. This one, it's only sine. So just without a graph, you must be told if this is going to be a sine or cosine function. So without a graph, we have to specify, is this sine or is this cosine, because we can't actually see the shifts. Anyway, that is all we have here. That's what we're going to be practicing for the rest of the day, finding those features, writing those equations. Rewatch this video if you need to. Let me know if you have any questions, and I look forward to seeing you in class.